Hey everyone, I'm glad you could join me today on my presentation on FramES and how we use it at Eric Stärk to deploy Ranger at our customer Westlotto. This session will focus on the development and implementation of our FramES appliance, with a short live demo at the end. I will schedule some brain dates during SUSECON, in case people want to know more about FramES or just have a chat around Kubernetes, Ranger, or automation with Terraform and GitLab CI/CD. So let's get started. A quick run through today's agenda first. First, we'll talk about the customer and why they contacted us in the first place. Then about our initial FramES 0.9 implementation. After that, about our learnings and how we improved FramES together with the customer. The fourth point, which is very important for us, is it shows how we are driving our development with the help of friendly customers, but more on that later. And we have a quick look at our roadmap. And lastly, a live demo just to show you how it looks and operates. To start off, this is the team at Eric Stärk. This team doesn't only drive the FramES development and implementation, but also anything that's in the agile DevOps or automation space. Ralph Charlie is the business manager for DevOps, and I guess you could call him more or less our secretary. Anything that requires management, if it's internal customers or with partners, is his specialty. Sasha Zimmer is our solution architect for DevOps. His strong side is around pre-sales and telling our story in a way that makes FramES sound better than the invention of sliced bread. He's also great at getting a high-level overview of complex customer environments and where we can and can't help them. Ferdinand Zilcher is our hypervisor engineer. He's our interface for anything that crosses over into the hardware appliance space. VMware, Nutanix, backup or storage systems, you name it, he can usually install and integrate it. Myself, I'm Stefan Charlotte. I've been working in the open source space for about 20 years now, and I cover anything that touches agile, DevOps, automation, or the open source and Linux space. We probably should also mention Tobias in our software development team. He's done or coordinated most of the development in the FramES front and backend space and was a great help to the DevOps team. Okay, let's start with the interesting part, which is Westlotto and why they contacted us. So the customer, like many other customers nowadays, got set the task to implement a new container-based gaming platform. They currently only had VM-based workloads, and the container space was a completely new area for them. They also got a whole list of requirements set by the business. The new application needed to be fully integrated into the existing core infrastructure, because I guess it would be a tad expensive to buy everything new just for one initial application. We obviously needed to implement systems and plans for backup and restore, disaster recovery, and high availability. Existing platforms for load balancing, monitoring, and logging would have to be included into the new area as well. This obviously provides a lot of challenges, especially in a market where it's very hard to find experienced resources in the container space, because currently everyone is looking for them and they're in high demand. There are also a gazillion different tools in the DevOps space, so what to pick to manage the different tasks? It was decided in the end to implement Kubernetes for the container orchestration on top of the existing Nutanix hyperconverged infrastructure, which was already in place and used for things like Splunk databases and a few other things. Initially, the customer looked at implementing Kubernetes themselves, but after about a year, they realized how complex it is to run Kubernetes. Manage it, keep it up to date, especially because it is completely different to the traditional way of how they were running the workloads. So time was running short, and Westlotto decided to contact us for help. We decided to kickstart the customer. We needed a product simply to help them. So we utilized the Nutanix product called Calm because they already had the Nutanix infrastructure present and developed an in-house container to work in conjunction with it. So Calm was used to create the baseline, which is an Ubuntu-based VM injected with proxy settings, certificates, root CAs, and then on top of that, a standard Docker install. Once Docker was available, the container took over to install RKE and Ranger. The container was also built in a way so that it could take care of the day 2 operations. So we could run RKE and Ranger updates through the container, for example. FramES 0.9 was then implemented at Westlotto and enabled Westlotto to deploy Ranger HA clusters within just 15 minutes. We had to configure a lot of customer specifics in the Calm blueprint though. So proxy settings, root CAs, self-managed certificate chains, repository configuration for their internal Nexus server, the information for their local app repository, all this had to be added to the blueprint. So this resulted into a heavily modified blueprint with a lot of customer specifics in it, which is okay for few customers. But we also realized that this isn't a sustainable model when you want to grow your customer base, because managing a blueprint per customer could become quite tedious when you've got a large customer base. So after the success of the FramES 0.9 implementation, we decided to improve FramES further, tackling the scaling issues and make FramES infrastructure independent. The idea was to be able to deploy FramES anywhere. So would it be vSphere, Nutanix, or cloud provider, it should not matter to us. The container was already flexible enough to run anywhere, but Calm still had a requirement for an on-premise Nutanix platform. We therefore decided to keep our container, but exchange Calm for Terraform. This would give us two big advantages. Firstly, give our customers freedom of choice for the platform. And secondly, give us the flexibility needed to tackle all the improvements we wanted to add to FramES 1.0. So we could move away from customer-specific parameters that are hard-coded at multiple locations and build a generic tool that could be controlled with variables. We had the option to either use command line within FramES, but also put everything into a front end. A front end makes it a lot easier for customers with zero Kubernetes experience to get started, because simply clicking install or upgrade Rancher is a lot easier than running Helm commands on a virtual machine, for example, especially for Windows-based friends. We could go to a more container-based approach for application. This enables a more modular way of developing features and enhancements by making it super easy for our customers to upgrade the containers and roll back in case there are some issues. So we now had the baseline defined for what we wanted to achieve with FramES 1.0, so it was time to get cracking. We decided on creating an appliance that could be installed just like a standard Ubuntu cloud image. So no matter the underlying platform, it would come preloaded with our containers and setup wizard, but could still be deployed using things like cloud config as well. Internally, we are using GitLab pipelines to automate the build and upload of our appliance on internal changes. This automates the update process, and customers would always download the latest stable release of FramES. FramES would also bootstrap and pre-configure Rancher HA as part of the rollout. So this means the customer can start rolling out sub or worker clusters shortly after FramES was deployed the Rancher HA cluster. Okay, so FramES 1.0 went GA mid-February 2021. And we managed to greatly increase the ease of use for FramES and also incorporate all the enhancements we wanted to add to our FramES 0.9 solution. The core was still to automate the deployment of Rancher HA and Kubernetes by covering the day 2 operations, but now we were also able to run it infrastructure independent. So today we support Nutanix and vSphere, and with the release of FramES 1.1, we will also support Azure, AWS, and GCP. The FramES appliance doesn't hold any customer-specific data anymore. So everything is configured via variables once it boots, and this means that we only have to maintain one base image rather than one blueprint per customer, which completely fixed our scaling issue. Also, FramES 1.0 is now purely container-based. So this keeps the update process for the appliance itself as simple as possible, because rolling containers forward and backward is as simple as running one or two commands. And finally, everything within FramES can be done using a frontend, so there's no need to have any experience with Helm or kubectl to get started. Here's some more details on the components of FramES and how we build it. We are using a GitLab pipeline internally to modify the most recent stable Ubuntu cloud image. And we load the setup wizard or containers and also preload Ubuntu base images into the cloud image. And those base images are used further down the track to deploy the Rancher HA virtual machines or then any sub and worker Kubernetes clusters. This modified Ubuntu image then gets uploaded to a web server and is available as download either as an OVA, as an image file, which is a QCOD2 format, or a VMTK file. The reason for preloading everything into the appliance is so that customers could deploy it in a dark side environment as well, because we kind of found out the hard way that not every customer has internet access from their vCenter or even from the internal network. So the appliance itself is a setup wizard to configure anything specific to the customer environment, like proxies, repositories, root CAs, NTP servers, and much more. Then we run 3 containers within the appliance. One container is our front end, and in there we can configure things like the SSH Keypairs, which are later used, the infrastructure providers to talk to the endpoints, and then range HA specific settings. We also have a backend container that holds all our scripts to process the front-end data and then build the virtual machines in the backend. And the third container is a simple SQL database just to hold the persistent data that was entered by the customer. And we still have our container that was used in FramES 0.9, which now runs within the backend container to do the actual RKE and Ranger install once the VMs are deployed, and also performs things like the RKE and Ranger upgrades. The appliance does the initial Ranger bootstrapping as well. It will preload CSI and Node drivers, set up initial RKE and Node templates, and preload the most common catalogs, just to make it as easy as possible for the customer to get started once she logs into Ranger. We work closely with our FramES 0.9 customers, especially Westlotto, to install FramES 1.0. And this was done very shortly after we went GA. And the reasoning for that was that we want to get that feedback cycle started with the customer as fast as possible. So we rolled out more FramES 1.0. We integrated the existing Kubernetes clusters onto the new platform. This was done within a very short time frame. And then we just started to talk to the customer to pretty much get the feedback going and then enhance FramES even further to go towards the customer needs and wishes. And the solution was also designed in a way to integrate features quickly and to cover all possible customer scenarios as fast as possible, which is the beauty about just running containers, because it's quite easy to update them and then just do an upgrade on the customer side. And so we added things like supporting multiple root CAs, having a log viewer that shows the steps of the Ranger deployment, static route definitions in the setup wizard, or even simple features like anonymous login for Docker registries. All this could be done within just minutes or hours of work. Our roadmap is also constantly changed depending on customer feedback. We revisit our priorities at a 2-weekly basis at the moment to deliver what is most important for our customers first. So speaking of the roadmap, here are a few things we were looking at adding in the near future. Some of them are even already in beta, as mentioned earlier. So one of those things is adding in things like the cloud providers with the next release. So we're already testing connections to AWS, Azure, and GCP, and we already have a customer that actually wants to use FramES with Azure, for example. We look at integrating more storage providers like Longhorn, for example, and this will go into the baseline configuration. We're already using Ranger Fleet for a baseline definition, and this keeps growing with every customer to include what's important for their baseline. So we're building a big catalog within Fleet at the moment, and then customers can just select what they want as a baseline for their worker or subclusters, and this then gets integrated through FramES. We're also utilizing NodeVector for most customers for container security, and NodeVector is becoming more or less a standard for anything that runs in production for us. We also started to look at Harvester as our year-end goal to build mixed clusters with bare metal support. I mean, why would you want to pay for hypervisor in the Kubernetes space if you could just run Docker containers or Kubernetes on bare metal? This is pretty much everything I wanted to cover on FramES and where we want to go with FramES. But to finish it off, I still want to do a quick live demo. I just have to swap the screens around, so I'll be starting in a second. Okay, so I've swapped around the screens and the demo environment is good to go. So let's get right into it. So here the FramES appliance cloud image has been deployed on a Nutanix AHV cluster. It has been preloaded in the Nutanix image service, and then just build a stock standard VM as you would do with any cloud image. And the VM is powered on and good to go. So if you don't configure anything via cloud config like a DHCP or a static IP address, the VM would actually come up with no IP configured. But for that, you can just jump straight onto the console here, log in with our FramES and FramES user, and this will then start a setup wizard. In the setup wizard here, we could configure a static IP address, or we could select no, and then DHCP will be configured, network will be restarted, and then the VM will come up with an IP address. This has already been done, so I'm just going to hit exit here and show you the same information the actual setup wizard once the VM is up and running with an IP address. So the frame setup wizard is here on the IP 10.10.224/8080, which is where the VM is currently running. And here, all these information that are configured here can be configured on the command line, or once it's available, it can be updated or configured using the browser. So we can set the host name, the domain, IP addresses, or the standard network information we need. The information in here are what is required to actually launch the FramES application. So our containers are all encrypted, and therefore we require a key and a secret. Without that, the containers won't be able to start or boot properly, and the application won't be available. This is simply for us so we can make the download available to everyone, but only people who purchase a key or secret with us can actually use the appliance. Then we could set a proxy if required. And we could set the local apt repository, which needs to be an Ubuntu repository. We can set a local container registry here, even with the anonymous login, and even with the option to mark it as an insecure registry. People could configure static routes. Like we had Westlotto, for example, who are using 2 gateways within the same VLAN, and they had to configure specific routes to predict where the traffic should go. Then we can load root CAs, which is usually required for container registries or apt repositories or proxies even, simply so the appliance trusts the endpoint. And this here is the option to load the Ubuntu base image from the appliance itself, which is required in environments where there's no internet access from the vCenter or the Prism Central between Nutanix or VMware. So in this case, the image would be loaded from a local Nginx web server that is running on the appliance, and there's no internet access required to load the base image, which is then used for the Ranger HA servers or the subclusters or worker clusters that are built later on through Ranger. So once we mark the options, our demo environment is very simple, so we don't have to set anything. You could just click Launch Restart FramES, wait a few seconds, and then the appliance will redirect you to the appliance, to the application itself. So you see, we already logged in because it was cached from what I've done previously, but here would be the login screen. Without that, usually you wouldn't see any of these. We can define infrastructure providers. So I've already preset demo AHV provider, which has our name, then admin as the username or password, and the API endpoint, which is Prism Central in that case. It's also possible to create a new provider, for example, for VMware. Same deal, give it a name, username, password, and set the vCenter as the API endpoint. I've also added in some SSH Keypairs, just a standard public-private keypair. The private has been hidden for obvious reasons, and that is the keypair that is then deployed onto the Ranger HA nodes. So once the VMs are up and running, you could SSH directly to those VMs using these keypairs. I've also pre-built a Ranger cluster because doing the demo would just take way too much time for you guys just watching a log, which is not that interesting really. But we could kickstart another build with our clone function just to see what parameters we can actually set when we build a new Ranger environment. So here we just give it a name. I'll just give it a SUSECON demo2 name. Then we select the SSH keypairs we defined earlier. We select the provider. So we've already pre-selected the AHV provider because we cloned the one that was already built. These are all the standards that is recommended by Ranger for a Ranger HA virtual machine. And here we can select our cluster-specific information. All these information that get pretty much sucked out of the API endpoint. And it's the same for the VMware provider or any other providers going forward. As soon as you specify the provider details and we could talk to the API endpoint, it will be visible here. And you can just select whatever is required using a drop-down. So this is the Ubuntu 2004 image that has been preloaded onto the Nutanix image services. In the VMware space, we would create a content library and preload the image there. So you could just select the content library and the image that is required for building the Ranger HA in the VMware environment. Then we can select the subnet, which we want to use, and give the VMs another name. So we just call them SUSECON demo2. So in this case, with a redundancy factor of 1, which would be 3 VMs, as we would see if we would configure static IPs. They would be called SUSECON, demo 2, and then 1, 2, 3. We can also change the redundancy factor to 2, which is then 5 VMs, 3, which would be 7, or even 0, which means we would only build a single Rancher node. Here again, we can set a proxy, we can set repository mirrors, custom CAs, and manually manage certificates. These are all then be loaded into Rancher, the Rancher VMs, and so on. Here we could set Kubernetes settings if we wanted any extra settings, and the Rancher settings. So the most important setting here, which we have to update, is the name, because we then have to create a round-robin DNS entry for the 3 IP addresses so we can actually connect to the Rancher HA website. And then we just click submit. It's asking if we really want to do it. And it puts us straight to the log viewer. And within the next seconds, we can see Terraform is going to start doing its magic and create the base virtual machines. Once those are up and running and the IP addresses are available, our container will log into these VMs and start doing the RKE deploy and the Rancher install. And once that is done, it will also log into the API and the bootstrapping, which I can show you guys in a second. So this will probably take a good 8 or 9 minutes because our backend is not the fastest, but we can jump into the Rancher environment I built earlier, which is this one here. So in this Rancher environment, I haven't done anything manually at the moment. So we can just log in using the admin user, using the password that was set as part of the bootstrapping. We don't have to set the URL anymore either because it's already done as part of the bootstrapping. And now we can have a look what has been preloaded by our appliance. So if we look at, for example, the catalogs, we can see there's a whole lot of extra catalogs like the NodeVector, which we recommend using, the Nutanix one for the Nutanix CSI driver. We put in the Git Bitnami one, the GitLib one, just to give the customers a baseline to start with pretty much. We also create an RKE template. This is quite important for Nutanix specifically because we can configure extra binds in there which are required for the Nutanix CSI. We also pre-configure a node template, and in that node template itself, we put in all the informations that were actually used as part of the Rancher HA deployment. If you remember, when you create a Rancher cluster, you put in the Nutanix cluster name, the container name, and so on, and we pre-populate as much as we can just to make it easier for the customer to get started with deploying the worker or subclusters. We also preload drivers, especially the node driver. We've got an own Nutanix node driver, which is installed here, and that is required to actually build subclasses on Nutanix, for example. Yep, and this more or less concludes the demo. So from this point onwards, a customer usually takes probably about 2 minutes to update some of the configs, and then in the Westauto case, they were already building subclusters after 2 minutes or worker clusters, which is kind of the goal of FramES, just to get people started as fast as possible and make it as easy as possible. So yeah, thanks for your time and thanks for attending, and I hope this was interesting. And if there are any more questions, as I said, I will put on some more sessions during the time of the SUSECON. You can just book some one-on-one or group time with me, and we can discuss whatever is interesting. Great. Thanks, everyone. Bye.